I'm Tanya. Today I'm going to explain about asymptotic notations. Asymptotic notations are mathematical tools to represent the time complexity of algorithm for asymptotic analysis. It also analyzes the performances of algorithm by understanding how their efficiency changes as the input size grows. It mainly focuses on understanding the relative growth rates of algorithms complexities and fundamental trends. So we have three types of asymptotic notations. One is big O notation, which is represented as O notation. Second is omega notation, which is represented as omega notation. Third is theta notation, which is represented as theta notations. So now I'm going to explain about big O notations. Big O notation represents the upper bound of running time of an algorithm. It gives the worst case. It gives the worst case complexity of an algorithm. So it represents two things. One is the upper bound, and second it is a worst case notation. So this is the graph for big O notations. As you can see here, we have function n and constant c of n. So this is the expression which represents the big O notation. So f of n should be greater than c of g of n. So for example, let's take an example. Function n is equal to 2n square plus n. So as we can see here, we have to write an expression such that the f of n should be less than c of g of n. So let's take an expression 2n square plus n. Here the dominant, this is a quadratic expressions, and dominant n is n square. So now we should represent here we have to represent f of n in terms of c of g of n. So let's evaluate this expression. 2n square plus n is less than equal to c of g of n square. We will take n square because this should be less than this. So we are taking n square. So let's take n in this expression. Let's divide both sides by, let's take it as 3n square. Let's take constant c as 3, and let's divide both sides by n. So after dividing, we'll get n is less than n square, which we did before. Then we'll get n is more than equal to 1. So to represent 2n square plus n less than equal to c of g of n, that is this value should be greater than this value. To represent this, n should be greater than 1 and c should be equal to 3 or more than equal to 3.
Hi everyone, I am Sneha. Today I am going to explain type of asymptotic notation, that is omega notation. It is represented by the symbol omega. Omega notation represents the lower bound of the running time of an algorithm and its best case complexity. Let us see the graphical representation of omega notation. Here we have
topic is theta notation. This is one of the asymptotic notation. What is theta notation? Theta notation is enclose the function from above and below, since it is represent upper and the lower bound of the running time of the algorithm. It is used for analyzing average case of complexity of an algorithm. We choose f of n and g of n are the two differentiate functions and say that they have the same growth rate. In theta notation, they have the same growth notation. Let us see the condition of theta notation. If limit of f of n divided by g of n instance tens of infinity is equal to c. C is the range of between the infinity. Formally, the stated f of n is equal to theta g of n. This is the condition of the theta notation. S1 dot g of n less than equal to f of n less than equal to c2 dot g of n. Now, let's see the graph of the theta notation. Y-axis is time of complexity and axis is number of the input of the time domain, theta notation. So C2 dot G of n is the upper bounded, F is the function of the theta notation, C1 dot G of n is the lower bounded. Now let's see the example of the theta notation. 2 dot n square less than equal to 2n square plus n less than equal to 3n square. This is the example of the theta notation.